Perfect. All right, so my name is Sawyer. First of all, I just want to say thanks so much to Nordic APIs for putting this on. This is my first time in Stockholm. It's a great city. I'm having a lot of fun here. I'm from EasyPost. We're based in San Francisco. We're an American startup, an API company. This talk will have a lot of similarities to Evercam's, in that sort of I'll be going through sort of our journey from early stage startup, building our minimum viable product, and some of the significant challenges we face trying to scale from there. So we had the enviable position of getting a fair amount of traction after we released our product. So what EasyPost does is we're a very similar API in intent to something like a Twilio or a Stripe, where we provide functionality to developers' applications. The specific functionality we provide is shipping and logistics functionality. So where Stripe provides payments, Twilio provides telephony, we provide shipping and logistics services. So this is the type of thing you would do with EasyPost. This is some sample code. Not sure how well the resolution is coming through there, but essentially with a few snippets of a few calls to our servers, a little bit of information about what you're shipping and to whom. You can generate postage labels, and then we follow on and do a lot of tracking and things like that. So anyway, that just gives you some background on what we do. My experience as a result is very focused on this style of API. So we've seen in a lot of these talks, there's a lot of different flavors of APIs. A lot of APIs are very heavily data focused. A lot of APIs provide unlock business data. If a business produces a lot of data, they might make an API available to distribute it. We're much more heavily leaned towards providing functionality for developer applications. So the data that we provide is almost entirely regurgitated from what you send to us. We don't generate any data of our own. So this is we're very similar to a Stripe or a Twilio, but very different from something like a Facebook or a Twitter API. And that's everything else that I say should be taken with that in light, and that I don't know a whole lot about those other style of APIs, but this is our experience is very much in that vein. We did attend. So we started the company. Our first version of the product was launched at the beginning of 2013. So we've been around for about almost 2 years now. We were lucky enough to get to attend Y Combinator in the summer of 2013. So we started getting some good growth all throughout last year. But the major problem we faced, the title of this talk is re-architecting an API platform, because of our growth curve, our minimum viable product ended up breaking in so many ways that we've basically, between last year and this year, there's very little left of our MVP, to be honest. So that's some of the lessons we learned in taking a minimum viable product into a real product under the load of growth is sort of the theme here. So the first thing that we ran up against, this is Adam spoke this morning from Orchestrate about convincing the architect, convincing enterprises and customers to use your API in their products. There's a lot of reasons why they might not want to, but the interesting thing for us is that we drunk the Kool-Aid. I mean, we're an API ourselves. We want developers to use our product in their products to provide their shipping functionality. So naturally, our inclination was to use other people's APIs when building our own. So we start out with using platforms as a service for our infrastructure. We start out with using S3 for storage. We started with using queuing systems, things like that. So basically anything that we didn't consider core to our API, to shipping and logistics, logistics, we would go and find a third party to provide that functionality. So the problem with this is that we exist, APIs are great for our customers, but not necessarily great for us, because we exist at a different level of the chain, if you will, of sort of where the application sits in the ecosystem. So EasyPost, for example, is one piece of an end developer's application. So anything that breaks from EasyPost downwards, anything that we're relying on that has any sort of failure, any sort of reliability issues, is going to reflect poorly on us. The developer doesn't care that we're using, a platform as a service, that we're using Heroku or something like that for hosting. All they care about is that their application is going to be broken. So because you as an API provider, as an API platform, are one component of an application that comes out the other end that developers are hopefully going to build, you have to be very cognizant of this. You need control over your reliability and performance first and foremost. So this is what we discovered. We discovered that infrastructure is core no matter what sort of industry you're in. So we're in the shipping industry. We consider that our focus and our custom and our value, but we didn't invest enough in our own infrastructure and ended up paying for that over our first year of growth as just bottleneck after bottleneck sort of comes up. And if you're using third parties, you don't have a lot of control over that. So if you're using AWS and you have an AWS as a failure, you're down and your customers don't care whether it's AWS that was whether it was Amazon that was at fault or whether it was you. All they see is you. So yeah, this is just, we just want to say that no matter what your API provides, no matter what your core business functionality is, reliability, performance, security, and privacy have to be core for you as well. So what I'm not saying is to never use a third party. There's lots of times when using a third party makes sense. Obviously, we wouldn't have been able to iterate as fast as we did without using some of those infrastructure as a service providers. But you really have to pick your battles and be prepared when your application takes off and starts to grow, that you will have to sort of go back and revisit those things and make sure that you're in control of all of those aspects. So what did we do to solve this problem? That's just saying the same thing. So we built our initial MVP on Heroku, which is a platform as a service built on top of AWS. This meant that anytime Heroku had a problem, we had a problem. Anytime AWS had a problem, we had a problem. So the very first thing we did when we sort of decided that we needed to spend some time making infrastructure core to our business so that we could really meet those reliability standards that customers were demanding of us was that we moved off of, we took out some of those abstractions, took out some of those middlemen, and we moved to dedicated servers ourselves, but I think moving to something like AWS or something directly isn't a bad idea either. AWS is great, but just beware of the number of middlemen you put in place there on your, especially in hosting, because there's a lot of things that can go wrong there. I just do want to say that if you're going to use AWS, try and use reserved instances, unless you don't like your money. Hosting becomes very, very expensive if you start to grow very quickly. This sort of compounds with another thing I'm going to talk about later in terms of our architecture, but we started out with a very monolithic design. We heard a little bit yesterday about the difference between monolithic applications and sort of service-oriented or microservice architected applications. And if you have a monolithic application, scaling the application requires deploying more instances of that entire application. So it just compounds. If you're using AWS or some cloud provider and you're not using reserved instances, you're paying a very high premium for that hosting capability. We did the same thing with storage and queuing. So these are two other aspects of our architecture that we initially outsourced to third parties. We used S3 for storage. We used a couple of different providers for queuing over the our first year. We brought both of those in-house. So our thinking here is that so we're responsible for a lot more in this scenario. You know, we're not outsourcing these things to third parties, but we're okay with that because if we experience a failure, the downstream customer's application is dead anyway. So we're happy to sort of be in control of all of those aspects of our application. The other thing I want to say about this is that the thing that makes APIs hard isn't architecting the basic framework for the application. So not any, but most great developers are going to be able to put this stuff together. This stuff isn't really what's hard. This isn't the business value. This isn't the value that EasyPost provides to our customers. The value that we provide to our customers is all around shipping and those sorts of things. So when you're focusing on what's hard about your business, this stuff actually isn't that hard. But it's very, very important. And any deficiencies in infrastructure are going to make it very difficult for you to sell into enterprises. It's going to make it very difficult for you to keep customers happy because they're building their businesses on you. All right, our second mistake was that API platforms are not websites. We and a lot of our peers when starting out into the API world are coming from a background of website and web application development, usually developing for consumer-facing software. Consumer-facing software is very read-heavy. So this is, we're talking about persistence here, we're talking about databases. Anytime the database is going to be the bottleneck for your application almost all of the time in any application of significance. And our initial MVP was very much designed to be read a lot. We were very read heavy, but an API is, because you're not necessarily providing a consumer-facing application, you're probably providing a piece of business functionality, you're probably going to be a lot more writes than reads. So this was a big mistake we made in our architecture. We were not prepared for this. The solution is we learned to shard. All database developers know about sharding. Everyone's probably begrudgingly done it in their past, but you're going to have to do it. You're going to have to learn to do it. You're going to have to do it well, because when you're providing a lot of write throughput rather than read throughput, essentially you need more databases to write to. You need more masters. The only way to get more masters is to shard your data. The good news is that in an application like ours, because we're providing business value to specific customers, there's not a lot of cross-user interaction. We're not a social network. We're not joining data across users a lot. We don't have any friends lists or anything like that. Most user data is siloed in these write-heavy applications, and most of the people I've talked to at similar companies have similar experiences. So if you're in the unfortunate scenario where you have to deal with more writes than reads, at least hopefully you're in a situation where you can easily shard. So for us, that's on users. So a specific user is assigned to a specific master database, and then they stay there for most of the time. Automate this process early. The most difficult thing about sharding and dealing with your database is once it's big, it's impossible to deal with without downtime. So what you want to do is put processes in place to automate sharding your data across multiple databases and moving people from one to the other really early. This is really easy to do when you have very little data and very difficult to do when you have a lot. Our advice, if we were to do it over again, would have been to just start with where n is more than 1. Just start with 2 at the very beginning, because it's far easier to build this stuff early than it is to add it in later. So this goes back to the point about the first point here, that reads are easy comparatively, is that essentially the solution to adding read throughput and to adding high availability is just to add replicas. Just add read slaves and replicas to your masters, 2 ideally at a minimum. You can fail over for availability. So if the master goes down, you fail over, you promote one of your slaves, and the more read throughput you need, the more replicas you spin up, and then your application essentially can just farm out any read queries you have to the farm. The other option when you're looking at database architecture and sort of deciding how you want to deal with this is you're going to come across clustering as another term. It's another approach. Clustering essentially means you have a multi-master architecture. So you might have, let's say, 3 masters for one set of data. This is really great for consistency and availability. If any of those servers go down, there's automatically more than one in the cluster available to pick up the slack. But this is very slow. You get that consistency and that availability by having every write be farmed out to all the servers in your cluster. This is very dangerous. Be very careful that this is the right solution for you, because it's going to hurt performance a lot. Big mistake we made, and is very common for APIs like ours, is we started with basic authentication rather than OAuth, because there's very little at the very beginning in an application like ours. There's very little user interaction. There's very little need to delegate access to your account. You're basically just plugging us in to your application and getting all of our functionality, and that's all there is to it at the beginning. But you need more than one set of API tokens when you start to get into versioning. You need to be able to, for both versioning and for, there's a few instances where you want more than one API token. So you instantly start to get into complexity, even when you think you're not going to. So starting with basic auth, where you're just generating when you're just generating keys, as random strings and providing them to people, may seem like a good idea early on, but you're going to need to delegate eventually. You're going to need multiple API keys for versioning. So just my advice is to just do OAuth first. But my 2 favorite examples of APIs sort of like ours is Stripe and Twilio. Both started in a similar fashion with basic authentication. Both ultimately had to add connect functionality and introduce OAuth eventually anyway. So you might as well just start there. OAuth isn't that difficult. It's standardized. There's lots of libraries, lots of samples. Just bite the bullet and do it. You actually get the functionality of providing really simple API keys with OAuth anyway. If anyone's used Twitter's API, you've seen this. When you go into manage your application with Twitter, you can generate an OAuth token for your own account. So the basic auth functionality that you are going to be tempted to want is easy to get with OAuth anyway. So even if you're not using it to sort of delegate access, you can use it in a very simple way anyway. You just provide people with an access token in their account rather than generating a random string. So my last major architectural lesson was that we started with a monolith. We started with one application, one large application that provided our API functionality, our web functionality, all authentication, and we greatly regretted it. A lot of people will tell you that monoliths are easier. You want to build your initial version of your application this way. I disagree. If you take my advice from the previous slide, you'll be starting with OAuth anyway, which was you're probably gonna want to separate that into its own authentication service. If you have a database, if you have persistence, if you have queuing at all in your application, those are naturally better represented as services anyway. So you're really sort of stretching the bounds of the monolith, even for your MVP, in my opinion. Second thing that we did, huge mistake, so silly in retrospect, is that we built our API and our website in the same application. So this is just, APIs 101, build your API first, build your website as a client that hits that API. You end up getting lots of advantages. You're your own consumer, so you get the business development for free. So again, you've got, at the very minimum with your MVP, you've got an authentication service, you've got your API, you've got your website, your www service. So at minimum, you're starting with 3 or 4 services. So just bite the bullet and start with a service-oriented architecture. I'm surprised we haven't heard a lot about this. at the conference, I just wanted to mention Docker. If anyone hasn't heard about Docker, Docker is a very easy to use operations tool that essentially makes it really easy to containerize applications. So essentially you'll have, instead of having an entire virtual machine that hosts, let's say your database and your application or whatever, you split out each service into its own Docker container, which is essentially just a Linux container, and it makes it really simple to deploy this. So services, a service-oriented architecture, microservices, whatever you want to call it, are not as hard as they used to be. There's been a big movement in development recently. The term you hear a lot is DevOps. All of these types of things, DevOps, Docker, all of the stuff is meant, it's moving operations into the realm where developers can do it. Is nowhere near as hard as it used to be. So this, again, it just makes monoliths more and more unappealing to me. The last thing to say about monoliths is that they're extremely expensive. I was mentioning this when I'm talking about hosting. When you need to scale your application, if you have one piece of the application that you need to scale, you don't necessarily need to scale the whole thing. If it's a monolith, you do need to scale the whole thing because that's the only way to scale it, and it's expensive. There's lots of as a startup, you're going to need your money for lots of things. You may feel, even after fundraising, you will feel like you're not resource constrained anymore. But all you need to do is think about it really, really hard for a few minutes, and you'll find better places to spend your money than throwing it at extra servers to scale your monolith. Tamer from Pivotal talked yesterday about anti-patterns here. Lots of great advice there. If you're considering starting as a service-oriented architecture, definitely take a look at his slides again. The one thing he obviously advises against that I disagree with is to not start with services. I think you should just start there and get it over with. The biggest downside he mentions is that it adds a little bit of complexity to your deployment process. When you're deploying a monolith, it's very easy. You just push the new monolith up to your servers. With services, you might have a little bit of coordination that needs to happen, but this is something a good developer will solve in a couple of days with Puppet scripts or Chef or whatever their deployment tool of choice is. So setting up a continuous deployment process at the beginning of your application falls back into the same bucket I was talking about earlier, where all of this other stuff that you're going to need to build to provide an API platform that has nothing to do with your core business value, your architecture, your services, your queues, your database, all this nonsense, is easy compared to providing real business value. So you should just get it out of the way early, in my opinion. Because what you really don't want to be in the position of is where we were, which is where we got to the point where we were providing real business value. We have customers that are really happy and just want more business value, just want more features, more services, things that they were willing to pay for, and we're just wasting our time re-architecting things and doing them under load, which is much more difficult than doing them at the beginning of your build process. The upsides to services are, in addition to the ones I've already mentioned, building out your team, especially if you're located in San Francisco. Anyone who's experienced that hiring market knows that hiring people. I've heard it's actually really bad here too. Maybe it's everywhere. Developers are it's really hard to find great developers. There's more jobs than there are good developers out there. So when you have a service-oriented architecture, you can hire people who don't necessarily use the same technologies that you've already used for your existing components of your application, different programming languages, different pieces of your stack. And each service doesn't necessarily need to be the same as the ones that have preceded it. So this allows you to hire more people. It allows you to hire better people. It doesn't. It's we had an experience where we brought in a great developer who was a Python developer. Our main application is a Rails application, and he was being productive on day one because he wasn't fighting with Rails. He was building his own service in Python. Service discovery, Tamer talked about this. You can use console, etcd. The advantage he didn't mention about service discovery is that you can use it to spread load. You sort of have an internal load balancer built in with service discovery, so it's great. Service discovery is awesome. Right tools for the job, that's similar to team, and low-hanging sharding fruit. So we talked about if you have a write-heavy application, you have to shard a lot. Splitting out services gives you a really easy opportunity to add databases specific to those services. So anytime where that makes sense, you get easy sharding for free. Thanks very much. If you use the EasyPost API to generate a postage label from our office to you and send it to me, I will put it on a t-shirt and send it back to you. Otherwise, look forward to questions in the Q&A period. Thanks so much.